the amount of people that put controllers out in, whether it be a bucket or something like that, to try and keep water away from it.
You got a photo of your neighbour?
There is one there, yes.
You'll understand it when we get to it. The reason is corrosion, electrical, electronic failure. You can get shorts, you can get open circuits, cables rust, all that sort of stuff. And worst case, if you get your 240 volts connected to the gear that's driving it from your PC, you could destroy your PC, or even worse. Water and power don't mix. Again, it seems pretty logical, but a lot of people out there don't realise 12 volt, 24 volt, 5 volt, yeah, you can get away with it. 240 volt, it's lethal.
Yeah, I've got
This is working really well.
ECG4, which is...
You want someone over there?
Okay, no, it's all right. Electrocution death, electric shock, can happen to you, it can happen to your family, it can even happen to a visitor. Some little kid runs into your yard, you've got a cable, you've got a box there that's live at 240 volts. You can't control everyone all the time.
The box will do 16 different SPI strings.
Okay, water and connectors.
16 strings of lights.
Now, a lot of people use various sorts of connectors. If it's just, again, 12, 24 volts, 5 volts, the connectors, they're probably going to be okay, but if it's data, DMX, you are going to have trouble. You get a bit of water between the positive and negative DMX signal, and you could end up with lights not working, whole sections of your display not working. Again, try to keep water out of your connectors. Both plug-in or solder connectors. Some of the connectors out there are waterproof, some of them are water resistant. The ones we get from Ray, I wouldn't call them waterproof by any means, but they're pretty good. And water and lights don't mix. A lot of the lights that we get, I really having trouble with this mouse, there we go. A lot of the lights we get are IP68. Yeah, right. They're not. The IP rating for the Chinese lights, take it with a big grain of salt. Realistically, they're probably going to be okay. About 5%, 10% will probably fail, either due to electronic failure. I put a lot of it down to water getting into it. Whenever I cut a pixel out, I have a good look at it, and quite often I'll see rust inside. Even though they're fully encapsulated lights, it just needs one little tiny pinprick of a hole right down into the, whether it be around the LED, whether it be through to the chip side, down past the wire, you're going to end up with a failure.
That's why I prefer using strips a lot of the time. So
Yep.
with strips, you've got a plastic sleeve that goes all the way over. The only thing you've got to worry about is the ends. A good dab of silicone on either end will ensure that you don't get any water in. Where pixels, each one's individual. And
Exactly. Controllers, use a decent box. Your $5 lunch box from Coles is probably not going to do what you want. If it's underneath your front deck or underneath the knees, yeah, it's probably going to be okay. But I've seen too many people say, oh geez, I've had problems with my controller, and when you have a look at it, it's rusted. The whole bottom of the board's all badly corroded because it's been sitting in water for days or weeks. And I've seen a couple of power supplies the same way.
to add to that, you see my boxes here, they're not actually really weatherproof, but they're actually out there exposed, very exposed areas. But what I do use is a tarp. So I wrap it in tarp. So, you can get away with using cheaper non-waterproof boxes, but you need to use something protected.
Mount the boxes out of the weather, whether that be a tarp, whether that be under the front deck or under an eave or something like that. I know some people actually just use inverted buckets. Paint them up so they look part of your display. Paint them up like a bit of a present or something like that. When closing the boxes, a lot of boxes have got different sealing methods. Some of the ones that I've got, this one here, actually has a foam strip all the way around. When you clamp it down the first time, the foam strip's great. Open it up 12 months later, it all starts to tear apart. Some of it sticks to the bottom of the box, some to the top. So the second time you go to close it, it's not waterproof. These ones here have an O-ring. Others actually have various different sorts of bits of plastic and stuff like that. If you're not sure if they're going to be waterproof, wrap tape around them. Like actually around, I don't think I brought one with it, but I actually tape around the seal here with electrical tape, put half a dozen wraps around. It's going to minimise the amount of water that gets to the seal, so if it does leak, it's not going to leak much into it. And airflow. Now, Ben, you know the boxes that we're building at the moment for our controllers have got 2 power supplies, 2 P2 controllers, and a couple of fuse boxes, and in my case a 240 volt fuse as well. That's pretty tight in a box that big. So they get very warm. So all my boxes have airflow through them, whether it be forced airflow with a fan, whether it be just the way the box actually sits vertically that way. There's actually air in the bottom, and this is just a natural ventilation out the top. Have a think about it. Some people don't worry about it, others do. I tend to push a lot of my power supplies pretty close to about 70% or thereabouts of their maximum rating, so they do get warm. Oops. Here's a couple of box examples that I did a couple of months back. These are a box from Masters that we all thought were a great box. They have an O-ring seal right the way around them. They're not designed for this sort of stuff. What they are designed for is if you've got a 4-way power board and you want to actually run a 4-way power board outside. So you run your power board out to wherever, and you've got 4 extra lines in the bottom there that you can run your 240 volt in and actually put your power to your power board. That was 5 minutes in simulated rain. All it was just a sprinkler sitting on top of it, and that's wet. It was soaking wet. These are the new boxes that we've sourced, and again, that was probably about 10 minutes in the rain, not a speck of water inside. These ones are a very flexible, very thin plastic. These ones are, you can still push it around a bit, but they're a much harder plastic. Just seems to work better. These are a couple of my boxes that I've built, and you can see that they're fairly tightly packed, hence the need for some extra sort of airflow. This one here isn't finished yet. That corner's actually full of DMX stuff. When you're doing your power, a lot of people just have a little tiny lead coming out of your box. You'll connect an extension lead and run that back to your deck or your external power point. If you can, if you're doing it yourself, run a single lead right the way back as far as the power point needs to be, rather than actually joining it outside. Some people either haven't got that experience, haven't got that knowledge, so there are ways around it. There's waterproof 240 volt connectors outside. I think I've got some pictures of them here. Never ever, you'll see why in a minute, lay power boards in the yard unprotected. We get rain during summer. And here's some examples of some weatherproof or very weather resistant external power boards. This one here is a great one. I've got a couple of these at home. I think David AVD uses that style over there. They can be hung up from a stick or something like that. Some of them actually have a little plastic stake to drive in the ground. They keep the 240 volt connections out of the water. This is a neighbour of ours. Was a neighbour of ours.
Yeah,
The neighbour from hell. She's now a neighbour of Graham's. We ran it to Bathurst.
I thought you meant was because she electrocuted herself.
Jacob and I snuck up and took this photo.
No, we didn't.
Sorry, somebody else snuck up and took this photo with an umbrella. Because if you look here, it's actually raining. Power board. A lot of these controllers and power supplies are not rated for outside use. They're rated to be used undercover. Extension leads. By the way, that's mine. That extension lead's mine, and there's another one there somewhere too that's mine. When she offered them back, I went, don't worry about it.
Just get out and let's go.
Yeah.
And I found my solar lights.
You did?
Yeah.
At that
Heard
place?
those?
Funny about that, isn't it? After you warned me.
No comment.
She's not plugging your solar lights.
Yeah, she took 10
She's a
solar
mad
lights.
witch.
She's a lovely person. She's no longer my neighbour, that's why I don't mind it. Sorry, Graham.
She's probably listening.
Don't care. She's no longer my neighbour. When you're doing connections, for your, whether it be for your lights, whether it be for your DMX connections or whatever always solder the connections, don't just twist them. I do twist and tape when I'm doing a quick connection to see if something works. But otherwise, if it's going in the display, if it's going to be a permanent thing, it's always soldered with heat shrink over it. And the reason is, yeah, corrosion. You can get water in there. The copper will actually corrode over time. It'll eventually break, but it'll also track up the copper. So even though you think, oh, that connection's bad, I'll cut that connection, could be 2 or 3 feet up the cable before you get back to decent copper. Heat shrink joins. Always heat shrink your joins. And additional elastic into the heat shrink. Now, we learnt this one down at Canberra last year, and what Aussie Phil used was a 5mm syringe, I think it was. And he fills it up full of Silastic. He actually puts it onto the end of the silicone gun, squeezes it, and it just puts the silicone into the 5mm syringe. He just used either a thick needle or some sort of cap to inject a little bit of silicone inside the heat shrink, then shrink it down. When you shrink it down, it actually pushes the silicone right along the heat shrink. Some of it comes out each end, and it's a fully waterproof, pretty much permanent seal. Works really well. I don't tend to use it. I tend to just use heat shrink, shrink it right down over the wire and give it a good squeeze. I normally don't have any problem getting any extra water or something into the connection. Some of you haven't soldered before, I would assume, fairly new into it. Here's how to join 2 wires. Lay the wires over top of each other, wrap them round like that. What you end up with is a nice connection that's actually the same width as the cable. The reason you do it that way rather than putting them together and just twisting them around, when you lay that over, it makes it a bit thicker, and sometimes you can't fit your heat shrink over top. When you've done that, solder it, give it a good dose of solder, just check that it's all the way through the cable, and don't forget to put the heat shrink on before you solder the wires.
All the rubber grommet.
This guy didn't, and we've all done it. Yeah, there's the little, well, that's what yeah, it's a 2mm syringe, but yeah, that's pretty much, I use the 5mm, same deal. It works really, really well. You can get those at most chemists. They'll ask you what you want it for and then look at you very strangely when you say Silastic.
That's a good try.
Waterproof connectors where practical. Not always practical, or if they're inside a box and you're using connectors, you don't have to go waterproof. Here's a couple of different connectors. These XLR ones, they're not waterproof, and if they do get wet, they corrode badly because there's a bunch of different metals in there, and they'll rust, they'll corrode, they'll really play up if you get them wet. These ones here are the Ray Wu style. There is missing from this photo, there's a little red O-ring that goes around there, and that's pretty much your waterproofing. What I do when I take them off at the end of the season is get some WD-40, give them a little spray in both ends and put them away. I've been using some now for 4 years, and they're still as good as the day I got them. Here's a couple of different sorts of connectors. These are the Stellascapes ones. I use those on my Megatree and a few other items. A few of you noticed these sort of connections that I've got on some of my items over there. They're not waterproof, but they're designed to go on the back of a car. They're an Anderson plug. I use those for 5 and 12 volt injections, high current. They're good for 50 amps. And those work really well. They don't corrode. Even though you get water into them, they don't corrode, so they will be good for years and years outside. Cable glands. I do have some cable glands here, which I'll pass around. These are some of the ones that I use. But there's a multitude of different sorts. The reason I use cable glands is it reduces the chance of you actually pulling on the wire where it goes into the controller inside. So if you pull on one of your cables because it's just that fraction too short, you're not going to pull on the controller. All you're doing is pulling on the cable gland. There's types for all budgets. If you're a cheapskate, you can actually get away with this style. I don't like them, but I do use them on our large white boxes that we've got. The larger ones. Who got those? Was that you that got them?
Oh, Mark got those.
Oh, that's right. This was too, yeah. They're a fairly flimsy, large white box, but they work really well for some large controllers. I've got 3 of them. I use 2 in the display. These here are great on the bottom where you've got cables coming in, but there's no strain relief, there's no nothing. So it's basically just to stop bugs getting into the box, and even then they don't do a great job. These ones here are the ultimate. You've got a frame which mounts to your box, and these individual sections here can be bought for the type of wire that you're putting through. 1 wire goes through 1 hole. Most of us tend to put half a dozen wires through each of the entries, so I use this style, which is what I'm handing around now. You can get them in about 5 or 6 different sizes, and they work out about 20 or 30 cents each. Buy them off eBay and they work well. The white ones that are going round aren't UV resistant, which is a little bit of a bummer. The black ones are. I've got some of those that are 5 or 6 years old and still going strong. Lights. Mentioned earlier, some of the lights aren't waterproof no matter what the IP rating says. Sometimes when you have a look at them, they've either missed the epoxy seal, or there is no epoxy in there, or they're filled with Silastic. Have a look at each of the lights if you've got this style pixel or LED set, just to make sure that there isn't a hole there, there isn't anywhere water can get in. If you're going to actually seal it, I'll get to that in a minute. Strips, Eddie mentioned, they need sealing at both ends. There's a couple of different ways of actually sealing it. If you're going to seal it with Silastic, use neutral cure Silastic. Don't use acetic cure because it will eat away the copper. These are lights that I bought 4 years ago. They weren't sealed at all around here. There was actually silicone around the LED, but where the wires went in, there was nothing. So I ended up having to seal the bottom of 5,000 lights. I don't suggest that. Here's one that I did early on some strip, and all I used was fill it full of Silastic and use some heat shrink. As the heat shrink shrinks down, it pushed the Silastic right on inside to about here. So there's a nice weatherproof seal. No water's going to get into that. Here's another one that I did on my Star, which, because of the design of the strip, it actually had holes in the outer sheath, in this cover over the LEDs. It had holes everywhere, little defects. So I ended up putting them inside some clear PVC tube. And well, they're 3 years old now, and the tube started to darken a little bit, but there's no problem with the LEDs. Some tips, or one tip. Never mount the board on the bottom of a box. I mean directly on the bottom of a box. The reason is, if any water does get in there, it will actually go to the bottom of the box. Here's my lead tricks from many years ago. This is actually upside down. This is the bottom. You can see the 2 controllers there and there. A little bit of water got in. At the end of the season, when I pulled them apart, they actually fell to pieces. So I learned, always use a standoff of some sort, whether it be a little block of wood, preferably a plastic or metal standoff. If water gets in, don't worry about it. Turn the item off, open it up, work out, have you forgot to tighten up a gland? Have you missed the rubber O-ring or something like that? If it's 240 volts, make sure you dry it fully before you even think about powering it up, and seal the leak up. That's it. I had one floodlight, very similar to what Eddie's got over there, homemade floodlights, that probably about 10 days I noticed that it was green. And I thought, oh geez, it actually must have a bit of a failure in the blue and the reds. I'll get to that, I'll get to that. After about a week I thought, oh well, I'll get over there and actually work out why it's green. Every time it come on white, you could see all the lights, but it was very green. When I went over there, it was actually algae growing on the inside of the glass. It was full to the brim of water. It had been running for 2 weeks, full of water. All I did, pulled it apart. That's actually the board. I had to replace the connectors and the wire. Everything else is perfect. So all I did was I actually threw in some silica gel to help dry it out, and that light's still being used. And that's it. I didn't have one other small display, but if you want to have a talk for a sec while I set it up.
Yeah, well, actually, I was going to throw over to you and say any questions today.
So one thing I used to use is Vaseline. Vaseline's good for plugs. Because whenever I unplug a plug, Vaseline in it for the year. I'm just saying, like, I don't use many plugs nowadays, but on the old lights I used to have, we used to use Vaseline. The plugs never corroded ever.
Yeah, I've done the same thing. We've actually got some dielectric grease from work, and I use the same thing on some of mine as well. But I find, you know, nowadays I don't worry so much about it, but just the WD-40 in there, if you do, when you take them down at the end of the season. But grease, Vaseline, anything like that works great.
Right, anyone else got a comment or a question for Dave?
Just get up the roof and dry Vaseline.
All right, well, have you got something else you want to show us?
Yeah, just a quick voltage and current measurement. This is more of a very, very quick run through, and then we'll have a bit of a break and I'll set up a couple of things over here to actually measure voltage current. Eddie's got a tree over there that's really, really good. Hopefully he'll actually disconnect his power injection so we can get the reason why we measure voltage and current, or voltage particularly. Why do we measure voltage? Can anyone suggest reasons why?
Make sure it's safe.
Make sure it's the right voltage.
As you found out.
Yes.
Someone plugged in some 5-volt lights into a 12-volt output. Oops.
Right.
Basically, yes, to make sure the power supply voltage is correct. One thing I tend to do is measure the far end of a set of pixels when they're on white, or LEDs, dumb LEDs, when they're on white, to see if voltage drop's going to be an issue. If I've got 4.5 volts on a 5-volt string, or even 4 volts on a 5-volt string, it's probably going to be okay. But if I want to add any more, I'm going to have some sort of injection. So this is a quick and nasty way of actually working out if it's going to be a problem. Check the polarity of the power supply. I know there's a couple of people in Victoria last year that had one of their outlets on a box wired backwards. They plugged in a set of pixels, oh, it didn't work, must be a problem with the set of pixels. They plugged in the next set of pixels, didn't work. Most sets of pixels that are bought now, if you actually plug them in backwards, they will blow the fuse. Some of the older ones will blow the pixels. The ones that I've got here for the Matrix, or sorry, for my Pixicles, I've powered them backwards a few times. There's no drama at all, they actually blow the fuse. There must be some sort of diode arrangement in there for dumbass protection. I think that was actually Alec that said that to me. Some multimeters. Multimeters you can get at your local electronics store, $10 through to however much you want to spend. Basically, this is a cheap and nasty one. I've got one almost identical to that at home as my backup multimeter. I think it cost me $15 at leading edge. There's Flukes, that's similar to the multimeter that I use, and that's just a generic multimeter that we're going to use just as a demo. DC volts, we're going to measure voltage first. Should point out, red lead goes to the plus volts, black lead goes to the common.
Don't plug it in the end.
Select the appropriate range if it's one like this. So if you're measuring 12 volts, select 20 volts. If you're measuring 240, you're going to be on, that's DC, that's AC, so you're going to be up here on the 750 volts AC. If you aren't comfortable playing around with 240 volts, don't. Get someone that is to help you with your work, because it is dangerous. The measuring leads go across the voltage source. When you measure volts, there's actually a very high resistance within the multimeter, so it doesn't actually take much extra current to actually drive the multimeter. Oops. And here it is, simply measuring a 9-volt battery. The red goes to the positive, negative goes to the black lead, and we're measuring 8.7 volts. It's obviously close to a flat battery. That's how easy it is to measure voltage. Current. Why do you measure current? Any suggestions?
Pulling 6 amps out of a 5 amp supply.
That's a big thing, yes. Overloading your power supplies. Or the controller. Some of the Rowu controllers, they're rated at 15 amps for the entire 27 channels. Most of mine I'm drawing over 15 amps. Some of them are about 30, 32 amps. I have actually upgraded the base of, I think I've got one there. I'll show anyone that's interested, I'll show later.
Current is also important when it comes to
Heating.
voltage drop.
Oh, voltage drop as well, yes, but also heating within the board, so.
Cable.
Yep. So we don't overload the power supply. Again, later, if anyone's interested, there's a few of us that have got fairly large channel counts to keep a track of what current, what voltage, what plugs in where. We've got spreadsheets, we've got lists of what goes where. One of mine is actually to determine the current as is. So in other words, with the cable going back to the controller, I measure the actual current. So I know this set of lights draws 6 amps, this set draws 2 amps. When I actually add all those up, I can go, yes, I'm drawing 17 amps out of that particular power supply, not 140 amps out of a 50 amp power supply. And it also gives an idea what cables may be needed, and also any additional power injection. As Eddie said, voltage drop's an issue. If you've got a cable, if you've got a set of lights that's drawing 6 or 7 amps, maybe you use a set of the 6-core cable, the alarm cable, and you double up on the positive and negative that supplies out. So it's going to halve your voltage drop in the cable. And voltage drop in that cable, if you've got 6 or 7 metre cable, can be half a volt to a volt. So it can make a big difference. And I tend to maximise any controllers. I tend to push most of my controllers, most of my power supplies to about 70% of the power supply and 100% of the controller output. Last year, my show drew 2.6 kilowatts, about 11 amps on 240 volt. That's the DC current. 363 amps DC. Are you going to run that through a, what is it, a 0.7 of a mil cable? No. So it's an idea to actually keep an eye on what, that's just a sort of an idea of what it can draw. DC can cause problems. If you try to draw that through a thin cable, it's just going to burn out, possibly causing fires. This one here, I don't know whose this is, I hope he's not watching. He said that he knows what current's going through what. I'm not sure how he knows that. Because he was blowing fuses at one stage and he didn't know why. He does have voltage and current measurement here, which I've never seen working, even though I've seen it actually in operation. Yeah, it's probably cursing, is he? And that's again one of my controllers. Current, measuring current. You actually have to break one of the conductors and put the multimeter in series. Here we have the multimeter. Black goes to common, it's set on amps, DC, and red goes to amps. You actually break the wire going to the actual lamp, set of LEDs, whatever, and from your power supply. So current actually goes out this way, through the multimeter, back to the lamp, and then back to the power source. And that's basically it. And we'll do a bit of a demo over here. I'll just get some lights out and all the rest of it if anyone's interested. Those of you that aren't can go off and have a little wander around.
Okay, final questions, comments for Dave? All right, well, when we first started this morning, we sort of thought the rest of the afternoon now would leave us free time for us to be able to interact and ask some of the display guys here questions. Is there anything at the moment that's burning? A topic you'd like to cover that we haven't covered yet? And maybe we can get one of our experts to give us a brief something.
Power injection.
Power injection.
Which we're going to go, we've got the practical exercise.
Yep.
Okay.
Okay, no
The
worries.
setup over there is perfect for power injection. The reason why.
But are we going to do that as a group, or is that just if you're interested?
Yeah, do it as a group if you want.
Do we want to do power injection as a group?
Yeah.
Yep. Who's going to take that? Dave, Eddie?
I'm happy to take it. Keep going.
Yeah. Right, well, do you want to have some more free time to chat and mingle? What do you reckon, another 20 minutes or so?
Sounds good.
And then we'll do injection. How's that? Beautiful. Thank you.